Welcome back to the deep dive. Today, we're taking aim at a piece of advice that's almost become dogma in software circles.
Right. The idea that Docker Compose is just a toy for your local machine.
Exactly. That you have to graduate to Kubernetes or something big the second you think about production.
And that's the assumption we're going to tear down today.
Yeah.
We went through sources detailing, over a decade of real-world experience that shows the complete opposite.
So the mission for you, our listener, is pretty simple. We want to give you a shortcut to understanding the why and the how of using Docker Compose in production.
And we're looking at material from someone who's been doing this since 2015, still uses it for most of the apps they build today.
That's a long track record.
It is. And I think it's important to clarify what we're even talking about. People often blame Compose when a deployment goes wrong.
Yeah.
But the sources make this critical point. Something like 95% of the moving parts have nothing to do with Compose itself.
Hold on, 95%. That seems high. What does that even mean?
It means the hard part isn't getting 3 containers to talk to each other. The hard part is setting up a secure, reliable Linux server.
Okay.
Getting your networking right, your security groups, your firewall. If you mess that up, Compose can't save you. But if you get it right, Compose just works.
And these aren't just little side projects we're talking about, right?
Not at all. The examples we found cover massive data analysis systems, regulated fintech services, and even hyper-efficient solo developer sauce apps.
So this is a method that works at scale, from one person up to enterprise.
That's the takeaway.
All right, let's dig into that core argument then. For years, the official Docker docs kind of warned people away from using Compose in production.
He did, yeah.
So why did developers start to, ignore that and push forward with it?
Well, those early warnings were really a reflection of the tool's maturity back then and, a bit of a push towards their more complex stuff like Swarm.
But the tool evolved.
It evolved fast.
Yeah.
And the real test became what the source author calls the pragmatic definition of works.
And what does that mean in a production context if you strip away all the hype?
It means checking off the absolute basics. Can it spin up your containers and, crucially, keep them running?
Stability.
Exactly. Is it consistent across different servers? Does it crash unpredictably? And does it have the features you actually need? Networking, logging, restart policies.
And the answer to all of that, since at least 2015, has been yes.
A very solid yes.
And there's this other huge win you get, which the source is called the parity advantage.
Oh, this is maybe the biggest selling point.
Mm-hmm.
Think about it.
Yeah.
The exact same docker-compose.iml file defines your entire stack on your laptop for development.
And in your CI pipeline.
And on your staging server and in live production. It's all the same.
You just eliminate this whole class of, well, it worked on my machine bugs.
You completely erase them. The
Mhm.
confidence you get from knowing your local test environment mirrors production is just massive.
Let's get into the proof. You mentioned some massive systems. Give us some of those aha facts that show this isn't just theory.
Okay, so the first big one is a large-scale Rails app. It was used for really intensive data analysis.
And the stack was pretty standard.
Super standard. Postgres, Nginx, Rails, Redis. The interesting part is that at its peak, it was running on 40 separate AWS EC2 instances.
40 instances. Okay, that right there completely shatters the idea that Compose is just for a single server.
It does, because Compose was managing the application stack on each of those 40 nodes. The scaling of the servers themselves was handled separately, but Compose provided that critical consistency across the whole fleet.
And what about that fintech company? The longevity story.
Right, so this company ran for 12 years, a mix of Python and PHP services, all orchestrated with Compose.
12 years is a long time in tech.
And it was valuable enough that it was eventually acquired by a company worth around $500 million. So this approach can clearly sustain a serious long-term business in a tough industry.
But I think the story that really nails the efficiency argument is the solo developer, the drop shipping app.
This one is just the perfect example. A solo dev, a Flask app, and the usual suspects. Postgres, Nginx, Redis, all managed by Compose.
And the numbers are staggering.
In just 6 months, he scaled that application to $90,000 a month in revenue.
And the really wild detail, the part that makes you sit up, is the profit margin.
A 95% profit margin.
How is that even possible?
Because his entire hosting bill for that whole stack was $100 a month.
$100.
It just speaks volumes. Your profit explodes when your infrastructure overhead is practically a rounding error. He didn't need a DevOps team. He just focused on the product.
Which brings us right to the question everyone always asks, but does it scale?
It's always the first question.
Because when people hear single server, they're thinking of a dusty old machine in a closet.
And the answer is yes, absolutely, it scales. But we have to change how we think about scaling for most web apps.
What do you mean?
For a huge number of applications, vertical scaling is more than enough. Just, adding more CPU and memory to one big server.
And the sources are really clear on why that's so effective. It's because most web apps are I/O bound. Can you break that down for us?
Sure. I/O just means input-output. When your app is I/O bound, it means it spends most of its time just waiting.
Waiting for what?
Waiting for the network for an API call, but usually it's waiting for the database to find and return data. It's not maxing out the CPU with calculations.
So if my app is just sitting there waiting for the database, throwing more app servers at the problem won't help?
It won't help at all. You're just creating more things that are waiting. But if you make that one server more powerful, more RAM for the database to cache things, a faster CPU, you directly attack the bottleneck.
So is there a benchmark for this? A metric you can watch to know if vertical scaling is still the right move?
Yeah, the sources suggest focusing on your P95 latency.
P95, so the 95th percentile.
Right. It means 95% of your user requests are served faster than that time. And the target you should aim for is somewhere between 100 and 150 milliseconds.
If you can stay under that on a single server, you're probably in good shape.
For a very, very long time. Users really start to feel lag above 200 milliseconds, so keeping that P95 low is key.
And we need to stress how powerful a single server can be today. The vertical scaling knob goes way, way up.
Oh, it's incredible. Single machine in 2024 is an absolute powerhouse. You look at DigitalOcean, they offer servers with up to 32 vCPUs and 256 gigs of memory.
You could run your entire database in RAM with that.
Easily.
All right.
Or look at a provider like Hetzner. You can get bare metal with something like 48 vCPUs, 192 gigs of memory, and a super fast NVMe drive.
And what does a machine like that cost?
Based on mid-2025 pricing, around $320 a month.
That is surprisingly affordable for that level of power, and it's so much less complex than managing a whole distributed cluster.
Way less complex. To put it in perspective, the source did a great calculation. Say you have an app with 10,000 paying customers.
Okay, so a successful business, generating maybe $200,000 a month in revenue.
Your traffic for that business might still run perfectly fine on a tiny server. Maybe 2 CPU cores and 4 gigs of RAM.
And even if you needed to upgrade to that $300 monster machine, it's a tiny fraction of your revenue.
Rounding error. Vertical scaling just maintains this incredible ratio of profit to complexity.
Okay, but let's play devil's advocate. What about the edge cases? What if you're not I/O bound? Or what if you get that viral, unpredictable spike? You go from 1,000 requests a day to 1,000,000.
And that's the exact scenario where people immediately say, you need Kubernetes, you need horizontal auto-scaling.
And they're not wrong, but
But the sources provide a much-needed reality check. Kubernetes isn't magic.
I think a lot of people assume that if you're on a managed Kubernetes service, that scaling is just instant.
And that's where the assumption breaks down. There's a lag, a pretty significant one,
A lag in what?
in provisioning the resources. Even with all the fancy autoscalers like Carpenter or serverless options like Fargate, the actual computers, the node, still have to spin up.
Right. The cloud provider has to find a physical server somewhere.
It has to find it, boot it, join it to the cluster, and then your app has to be scheduled and rolled out to it.
So if I get a huge traffic spike, I'm not getting 10 new servers in 1 second.
You are definitely not.
Yeah.
The source describes the time to get those new nodes ready for traffic as many minutes.
And during those many minutes, you're just dropping requests.
You're dropping requests if the surge is big enough. So the takeaway is that getting that auto-scaling to work perfectly and cost-effectively for those rare spikes is, and I'm quoting here, a pretty big engineering effort.
So it's not a simple switch you just flip on.
Not at all. It requires a sustained, significant investment in infrastructure engineering.
Okay, so let's pivot back to the low overhead world. We're sold on Compose, we're sold on vertical scaling. How do you actually deploy your code without a big, complex CI/CD pipeline?
The method detailed in the sources is just. It's so brilliantly simple. It uses the one tool every single developer already knows inside and out, Git,
Just Git.
by using something called a post-receive hook.
Okay, walk us through that. What is a post-receive hook?
You set up a bare Git repository on your production server. Then, when you're ready to deploy, you just run a command from your laptop, git push prod main.
And that prod is just a remote that points to your server.
Exactly. When the server receives that push, it automatically triggers a script the post-receive script.
And that script does all the work.
It does the whole dance. It pulls the new code.
Hmm.
It might pull a new Docker image. It runs your database migrations.
Rails db.migrate or whatever.
Yep. And then it runs Docker Compose, upper and D, with the new configuration. The whole deployment is orchestrated by that one push.
And I assume you can build in zero downtime techniques there, too.
Of course. A more advanced script can wait for the new containers to be healthy before it switches the traffic over. The core idea is that the deployment command itself is always the same.
And this is where the consistency really pays off. The source says this process is 95% the same across all projects.
And that is a huge win for developer productivity. It doesn't matter if the app is Flask or Rails or Django.
The deployment is always Git push.
It's always Git push. The only thing that might change is one line in that script to call the right migration command.
So let's lay out the full stack for this, the 4 main tools. Because I see Terraform and Ansible, and that might sound complicated to some.
That's a fair point, but they each have a very specific, limited job. First, you have Terraform. You use it once to set up the basic cloud resources.
The server, the firewall, the DNS records.
Right. The stuff you do with your cloud provider. Then you bring in Ansible.
And why Ansible? What does it do that Terraform didn't?
Ansible configures the software on the server. It installs Docker. It sets up that Git hook, configures your web server. It's idempotent, so you can just run it again and again to make sure the server's in the right state.
So once that one-time setup is done,
Then your daily workflow is just Docker to run the app and get to deploy it. You automate the setup so you can simplify the workflow.
it's an upfront investment for long-term simplicity.
Exactly. And the sources say that with this setup, a brand new app can be deployed and secured over HTTPS in about 5 minutes after that initial Ansible run. That speed is a massive business advantage.
So wrapping this all up, what does this mean for you listening today? I think the evidence is pretty clear. Docker Compose is robust. It can handle massive scale when paired with vertical scaling, and it dramatically simplifies your entire deployment pipeline.
It's not just a dev tool anymore. It's a strategic choice. The core value is stability, consistency, and incredibly low operational overhead.
It lets you focus your engineering time on what actually matters.
On the product, on the thing that actually makes money, instead of on infrastructure that might be total overkill for your needs.
Which brings us to a really provocative closing thought from the source author.
Yeah, this was interesting. The author observed that AI is starting to really change how people find technical information.
How so?
That it's consolidating organic traffic around these very deep synthesized knowledge sources, like the ones we've been discussing. And this might actually make creating detailed courses and deep dive content less financially sustainable for individuals in the future.
Think about that for a second. The very knowledge that lets a solo developer make $90,000 a month with a $100 server bill.
That knowledge is incredibly valuable.
Yeah.
And as the economics of sharing that kind of expertise change, it raises a big question. How will the next generation of builders learn these practical, battle-tested shortcuts that save just immense amounts of time and money?
It's definitely something to think about as you decide on the architecture for your next project, and maybe for its future too.